Hi, I'm Kenton Shepard of NACHI TV. We're here today with Greg Gepter of Gepter Septic, just outside of Boulder, Colorado. And Greg is going to show us a drip septic system. Greg, thanks for being with us.
Sure. Well, in this situation, what we have here is a house that was built probably in the 50s to 60s, early 50s to 60s. Septic system was undocumented, and there was nothing on file with the county health department or anything. So at that point, the house is gone up for sale. So I found out they needed to put a new septic system in. The engineering and permit process have already been done. They have determined through the engineering that the soil has a high enough clay content and the perk rates are slow enough that they recommended putting in a low pressure drip system or a bell pat system. There's a lot of names for that, but it's more or less a sub drip irrigation system.
Does the name have to do with the manufacturer or with the type of system it is?
From my knowledge, in this area, there was two guys that started this type of system, and one of them had the last name Bell and one did Pat, so it became a Bell Pat. Mm-hmm. And a lot of the engineering companies in this area have adopted this type of technology and this type of system. A lot of them are named different, but they're usually the function's always pretty much the same.
Uh-huh. So this is where we start out. Is this just a clean out right here?
Exactly. We used the existing sewer line coming out and tapped into it, and then supplied a clean out here just for future. If they have a problem in that, they don't have to put the rotor-rooter inside. They can clean the sewer line from the exterior.
Is there a minimum size for that riser, that clean out riser?
As far as height?
No, as far as diameter.
There's not. We generally just run all 4-inch. There is, I think in the code you can go down to 3-inch if you want, but it's usually we just run all 4-inch pipe is what we run everywhere.
I'm just wondering if there's anything in particular inspectors need to be looking for as far as the clean out goes. Can it be buried? Does it need to stick up a certain amount? That sort of thing.
Now in this county, it's not required that we even put a clean out in. Mm-hmm. A lot of counties, the surrounding counties, it's mandatory that we put them in. Usually it's within the first 5 feet, so that they can get the whole sewer line. Mm-hmm. In certain counties, Adams County or what they call Tri-County Health Department area, they require a clean out within the first 5 feet, and then anytime that you have a combination of two 45-degree bends, mm-hmm. so that, if they do get an obstruction in there, it can be cleaned out easy. So different counties have different regulations on the clean out.
So inspectors across North America should find out what the local requirements are.
Exactly.
So as we follow the main sewer line out here, we come to a point at which it changes into a larger pipe.
Actually, this here is what we call encasement. The domestic water coming in from the road comes in right in here, and Boulder County code requires us to encase the sewer line anytime we cross the water line, so that there's no chance of this sewer leaking into the water line. Sort
of a secondary line of defense against contamination.
So if anything does happen in the sewer line, it breaks, and if it did break, mm-hmm. You have protection of 2 pipes, one inside the other, right. And then you have a protection of it being encased so that it won't ever have a chance of polluting any type of water, domestic water.
So it looks like at this point anyway, we're probably down a couple of feet below grade. Will that depth vary with the depth of the frost line in different places?
Generally not. Sewer lines aren't like water lines. They're not charged all the time. If they have the proper slope on them or the drop going toward the tank, you should run water and then completely, run dry. Mm-hmm. So you don't get the freezing problems that you do, with water lines that are charged all the time. Yeah. And then if there's nobody using that water, it's still water, and that has more chances of freezing.
I guess the only exception might be if it weren't installed very well. And
exactly. If there's low drops and stuff in it, it's not installed very well. That's why the bedding, when it be installed, is very important to keep the pipe at a constant grade, so you don't have any little dips in that, so that it could trap water, and then in a cold year or cold season, it would freeze. And then you get kind of like a damming effect where it starts damming up, and then you'll get it to freeze up. But generally, you'll get you know, the water to run through, and then it'll be drained. And somewhat, you get the bacteria in the tank will actually create a little bit of heat, and then you will get some heat coming, you know, back up through the pipe.
Right.
Not a lot of heat, but it does seem to help.
Yeah. If we're looking down at this, all we see is dirt. Is this actually bedded in gravel?
No, it's not. We use the on-site bedding. A lot of times what we do is when we've used gravel, or actually never have used gravel, but in the past we've heard about them people using gravel or pea gravel. It will trap moisture and then give a place for tree roots to go for, and then the roots will have more of a chance of breaking into the sewer line. We don't use bedding. We spend a lot of time picking out the soil, putting around the existing soil, and then packing it around. It's always one of those things when you have a sewer line here, you put gravel around here, you still have the existing soil here.
Right.
So I mean, bedding is depends on how it's bedded.
Yeah. Well, shall we follow it on down the line?
Sure. So this is a little bit different tank than that we saw the other day, but this is what we'd call a 3-compartment tank. Meaning that this tank is 1,000 gallons in this part, and then there's the pump station in the second. So there's actually 3 walls in this tank.
Do they completely separate? I'm sorry.
Yeah. It works as a baffle in between. So this would be more or less like a regular 2-compartment septic tank, and this would be a pump tank. But in this manufacturer, they cast it all in one. And this last baffle sealed really well, so we don't go any effluent going into from this compartment into this.
Can we open these?
Sure. Again, this is just a little bit different type of riser system. This is a Frelo riser system, and that way they just screw on and they can be adjusted. Again, we come in here and we'll see the inlet T that's installed, and there's people living in the house, so you can see the water level is starting to come up because this system's probably been installed for about 2-3 weeks now.
Part of what I was looking at earlier said that it was important that the effluent be screened really well, since the tubes have fairly small orifices to let.
So then what we'll do is the solids and the effluent will drop in this chamber and then settle out, and then you can see in this baffle wall here, there's another baffle on the inlet side of that baffle wall, and then this would be considered the outlet baffle, and then in this we have a effluent filter. So, and this is the filter that the effluent has to come up in through the bottom and then come out through this way, so that it will screen everything before it goes into the pump chamber.
So that's just a screen filter?
Exactly. And then this is the actual alarm when the level in this tank and this filter doesn't get cleaned often enough. Then this mechanism will come up and sound off an alarm to let them know that this filter needs to be cleaned.
So it's like a float switch similar to, say, a sump pump.
A high water alarm. Yeah, it's the same type of switch. So, and it's simply just pulled out, hosed off, and then reinstalled. Just making sure that it's pushed down is one of the biggest installation.
An inspector opening this up, are there any particular defective conditions they might be looking for?
Just on the outlet baffle, on the outlet baffles or the inlet baffle, any of the baffles, just to see if they're in proper condition. And then one of the things, like with concrete tanks, always you'll want to look at the condition of the concrete. We go to a plastic riser here that gives us a little bit better corrosion as far as anything that breaks down the cement. So
guess we want to be looking to make sure that the outlet baffle was lower than the inlet baffle.
Exactly. And that should be, once this tank gets filled, there should be 3 inches of fall from the inlet baffle to the outlet baffle. And then from that baffle, it goes into the pump chamber. This is where the effluent pump sets.
Looks like an injector pump.
Exactly. It's pretty much what you would see, you know, in a sump pump in a basement or something. This is a low pressure system, so that we don't create a whole lot of pressure out there. So then at the point that these two fill up, and then the water will drop into here, then there's a control that's the lower one, the gray one, that will raise up and float up and then turn on the pump. Then it has anywhere from a 250 to 300 gallon douse that it will send out to the leaching field, up to the, and actually the first place it'll hit is up to the valves, the control valves for the zones.
So it'll send out 250 to 300 gallons at a time, and then it'll shut off.
Then it shuts off and waits until the house uses that amount of gallons, and then it will turn on again. So it's all, you know, set up by itself. The second float, there's a pump, float or control that's set up a little higher, just in case that something happens with the pump, the float, or anything in this compartment that gives the people a warning. And it's teamed up somewhat with this control over here, but it just, one of them will buzz, and there's a light on the control panel that will either be solid or blink, and that tells us either if it's a filter or if the pump's going out.
Gotcha.
Or if there's just a problem in here, you know, just in time with mechanical devices, those should be, you know, at some point they will have to replace this pump.
So that the lower switch is about right now it's about 9 or 10 inches off the level of effluent, and the other one is about maybe 2 feet, 2.5 feet above that.
Exactly. What it's the upper high water alarm is set up so that it will give them alarm prior to the water starting to back up and have backups in the house. So it gives them some, you know, usually we figure try to give them at least, you know, 6 to 10 hours of time at a normal use, and it all depends on their lifestyle of when it needs to be, you know, they need to get somebody out here to service this.
So we just need to make sure that the upper alarm is below the level of the inlet baffle.
Exactly. Because if it's up too high, the minute it'll go off, you know, it could be backing up, or you don't want it to back up and then go off. So make sure that alarm's at the proper height, elevation.
And there's some wiring in here, and for that alarm also, I guess that ought to not be hanging down in the effluent.
No, and there's one thing that's that you need to be very, very particular about is how the wires are spliced inside of a septic tank or lift station. The biggest thing is the gases that get created in a septic tank or lift station are very, they attack metal. So if you put just a regular plug on the end of a cord and then plugged it right into the pump and the float, like you can buy them out of, you know, the big box stores, in time it will actually, that gases will corrode and that plug will just fall off. So being like a sealed airtight box like we have installed here, this is what we use, a Aranco system spliced box. And everything's actually watertight and airtight. So none of the gases can get inside that box to corrode, because that's the worst thing that would happen with that is if it does get corroded and it corrodes the warning light and that goes off, and then all of a sudden the pump happens to keep running, and then the pump goes out, then you'll have a backup and no alarm.
Right.
So that's very important.
So we want to look for a watertight and airtight junction box for the splice, and also look at the connections where the wires enter the junction box, just to make sure that those connections are good.
A lot of times some people will actually hardwire them. If they're hardwired and you know, coated right and everything, you know, that'll work fine too. But it's just, you know, just the reason we use a splice box is just a lot easier to switch this pump out. We have a union installed in the top, so all you got to do is undo the union. This whole unit comes out. You can put, you know, screw a new pump on, pop it back in, run your new cord, you know, new cords in your cord grips, and then wire it up. And I mean, usually you can do something like that within a half an hour.
So if an inspector sees a couple of cords disappearing out of the side of the access tunnel, there might be a junction box actually outside, buried.
Exactly.
And where the splice takes place.
Yeah, there is other Aranco makes another splice box that is actually mounted here. One of the things you just have to make sure is that the air in here cannot travel through the junction box and get to it. It's not bad if the junction box is on the outside. It's just a matter of if it's all sealed right, so that one, we look at for ease of replacement. At the time that this is going to need to be replaced, you know, there's going to be a timeline that people are, you know, probably wanting to use a septic, and who knows what day or time of the year it's going to be. Exactly. So the easier we make it to replace is going to be a lot easier down the road. And thinking about making sure that, you know, that you're keeping everything that's, you know, all the electrical connections and everything in a air and watertight situation.
Well, electrical conditions are difficult enough when it's just water, but when you get effluent and corrosive gases, it's even more complicated.
Exactly. Another thing you can see from here that we have the pump that comes up, and for ease of removing it, it comes up and then goes back down like this. That you cannot see from just looking at it. At the bottom of this 90-degree bend down here, there's a 1/4-inch weep hole in the bottom of it. And what that does is when this pump turns on and charges this whole line up, and it'll fill that, you know, use that 250, 300 gallon douse. When that pump turns off, all this whole line will drain back into this tank. So none of this line will freeze. That is one of the biggest things too. Now if that hole wasn't in the bottom of that 90, this line would charge up, and the pump would turn off, be full of water, and then, you know, if we were in a cold time of year, then it would freeze up. So this is the pump line, and it'll come up toward the valve boxes where the valves are positioned.
So why does it split right here?
It doesn't split. I'll go over that when this line here is the one we're following right now.
Oh, okay.
So it's a continuous line all the way up to the control box.
Oh, I see what's happening. That's sort of probably part of the manifold, huh?
Yep.
So we've got two boxes with two valves apiece.
Exactly. So what we have here is we have this 1.5-inch pump line coming up to the top up here. Then we come into here for a pressure release.
Like a vacuum breaker?
Exactly. So that if this system gets at 250, 300 gallons, it doesn't shut off and just suck back to the pump and start over. So once the pump turns off, that'll break the pressure, so the vacuum breaker.
This pipe can empty, but these pipes will
drain into the leaching field.
Yeah.
So this one here, this system was designed with 4 zones. So that means there'd be four different valves, so that you could control each zone. What the engineers recommended, that each one of these, there should be one valve shut off every 6 months. So what that means is, like right now that we have this first zone is shut off, so it can dry out. And now it's new, but in certain times will be used. So then in 6 months they will turn this valve on and then shut this one. What that does is gives that zone a time to rest.
Right. Kind of like farmers rotating crops.
Exactly. And then what we do is, it lets the soil contract and lets it, with the high clay content, it swells up, and then the minute we can, cut the water off to it, and it starts to, contract, and then when you hit water again, it's ready for water.
Right.
So you just rotate it out, and then again, after you get to this one, then just rotate back this way.
Gives the ground around that zone a chance to dry out and sort of clean itself.
And then once from the valve, it comes out from the valve, and then you can probably see it on this one a little bit better. It'll come out of the valve and then down to a header. So the zone is actually 1, 2, 3, 4, 5, 6, 7, 8 pipes. So each zone in this septic or leaching field has eight pipes in it.
So each one of these cuts in the bank represents a pipe running down
exactly
that way.
So every 2 feet in this whole graded area, every 2 feet there's a pipe. So we're this whole leaching field, we're sending this effluent out a little in a big area. So that way we can spread the effluent out. That's why we use the pumps to spread it out in a small amount in a bigger area. So that way it can, you know, the idea is that there's in these pipes, it's a 2-inch pipe with a 1/4-inch hole every 8 inches.
Mm-hmm.
So water will go out into this pipe and drip out of the bottom of the 1/4-inch hole out of the bottom, saturate the bottom of this trench that was cut out with a trencher, 8-inch wide trench, saturate the bottom of it, and then what it'll do is the sidewalls of this sidewalls will get the water to come upward. And that's where you get your evaporation. They found out that with it being freshly excavated soil and this virgin soil will transfer the water up like this. So you can just imagine how much side trench surface that we have when you have this much pipe out here. So we have a lot of area for that effluent to soak away, and it will absorb quite a fair amount, but it's a combination absorption evaporative type system. So then we'll get the water evaporating up, and then you'll probably, the grass will probably darken up, in these areas because it's going to get more water and that. But then rotating the valves off will give it a chance to get the effluent going in the right direction.
So it requires quite a bit bigger leach field than the regular two-chamber tank with the trench system.
Yeah, and that's just because of the soil type. Because the soil it's got a lot more clay in it, so generally the percolation rates are higher, meaning the leaching field needs to be bigger.
Right.
Because the soil takes water slower, so we need more square footage leaching field wise. This type of system here generally takes about somewhere between 30 to 40% more area than a type gravel bed type ET system, but it all depends on the perk rates and the application on how many bedroom the house is.
Do you adjust the soil content at all when you cover everything up?
Nope, it's just backfilled with the on-site soil. What happens is we set up our trencher and usually start on the first trench it, put the pipe in, and the trencher's laser guided, so it cuts a trench level from here, as far as we go. Generally, they're about 100 feet long, not over 100. And then throw the pipe in and push the soil in, and move over 2 feet, and then cut another one in.
So is it crucial to be level?
Yes, it can be plus or minus an inch. We like to get it right on. It's just equally. You don't have spots that would be taking more water. If the pipe had somewhat of an angle to it, you get a lot of the water running toward the one end. Right. So this way, being level, it's going to take water consistently through the whole line.
I thought being under pressure might help even things out.
It does. And actually, I've heard about new systems now that they figure if we can up the pressure and get more pressure going to it and fill that perforated pipe, there would probably be more chance where we didn't have to be level. Yeah. With the bigger 2-inch pipe, generally it's nicer to have it level because it's not going to pressure up. As you imagine with that pump, you consider how many holes that are in this pipe, the pressure is going to drop pretty fast.
Right.
Like a hole in a water line, it doesn't take much and you start losing pressure. So
you're still dependent somewhat on pressure to move effluent the length of the pipes that actually form the field.
Exactly. So this whole zone also is all level. So this whole from the first pipe to the 8th one is all level. So this whole zone is level.
So we don't have to worry, but we're not moving effluent by gravity. We're actually still using a little bit of pressure to move
exactly.
effluent
We're
around.
Just trying to get the water out there faster than gravity.
Yeah.
And then there's on the other end, on the far end of on the leaching field, there's vent pipes. In a situation where you're kind of wondering how the system's working, saying you think that maybe you used a lot of water and you wanted to see whether or not it was time to switch a zone, you can pull the caps off, and those pipes are hooked to the first pipe directly. It has a 90-degree on it, and you can take that cap off and look down there and see if you see standing water, and it gives you an idea on what what your elevation on that water is. And then generally you don't see that too much unless you're getting toward a point where the system maybe wasn't quite sized right, or if the people are using more water than the system was sized for.
Or maybe they weren't closing off a valve every 6 months like they should
Exactly.
be. Yeah.
Yeah.
Those don't look like they'll, well, those are just barely at grade there. Should an inspector see the caps, the lids for
Yeah,
those?
there'll be time I grade that
Valve
off and
covers?
that the soil's swelled when you trench it like that. So they'll be at grade like that. So this type of system, definitely those valves should be exposed.
Mm-hmm.
Some people just don't like seeing that stuff. So as long as they know where they're at or it's marked, so that they can, you know, if the system's being, you know, the property's being sold, that the new people know what's going on. And
Right.
that is one thing with this type of system, and really any type of system that, you know, if it's systems or properties being sold to a new owner, it's really advantage to the new people to know what's on site.
Oh, exactly.
You know, they're dealing with so much, and a lot of times they never think about the septic system because they're thinking house and they've got a lot of things going on, turning the cable on, turning their phones on. But it is nice to, to maybe give the homeowners some of the documentation on the septic, and like this one, they definitely need to know that, you know, they need to switch the valve every 6 months.
Mhm.
And again, you know what the alarm does, what, you know, if they have the
Right.
alarm come on, that they have possible problems down the road.
So many homes we come onto as inspectors that are on septic systems, and the first thing they ask is, well, where's the tank?
Mm-hmm.
And, you know, sometimes you can tell, sometimes you can't. And
Yeah.
sometimes you have to find it one way or another with a locator. Or,
Yeah, and that's like this one here. We
electronic.
bring these type of tank lids here. All the ones we use we bring them to the surface of the ground.
Mhm.
You know, that way if they don't want to see it, they can put a flagstone over it, something that they don't have to dig for or anything. Especially if something happens into that lift station. You know, in a really hard freeze type of time where they can't dig that lift station up. You know, this way they just come out here, can unscrew that lid, and then get to the pump to replace the pump.
So there aren't a lot of defects that are going to be visible in a system like this that you won't see by looking in the tank unless you actually see effluent on the surface.
Surfacing effluent, you know, if they wanted to, they can
One of
look
the
down
risers.
the riser pipes and the vent pipes there and see, you know, the height of the water in there. That will give them an indication if one of the zones is getting more water than the other, and if they haven't been switching it right. Looking in here to make sure that you know, and generally looking in there, you can tell if it's been messed with or not. You know,
Yeah,
by seeing
yeah.
if there's somebody been in there. If not, it might be a question to them. You know, has this system been switched? Even on a regular type septic system, where some engineers will design, say they want 1,000 square foot leaching field, they will actually put two 500s in with a diverter valve in the middle and require the same thing. Where they're on 6 months on this one, 6 months on
switch
this,
back and forth.
giving a rest. The biggest thing that was really good type of system, but if it's not switched, they're only working off half of the required square footage.
Right.
So they're, you know, then they can fail this one. They do have a backup, but then it's hard to get this one to come back in the amount of time that you're using this one. So you can hurt this one also.
Go
in
from
time.
one crisis to another.
Exactly. I mean, they do. It is simple enough at the time just to turn the valve so that you can switch it to the
Right.
newer system that hasn't leaching field that hasn't been used.
You have to know about that, though.
Exactly. You have to know about that. Most of that information in this area is all documented with the county health department.
Just going to say, just like other septic systems, it's probably important for inspectors to get whatever information they can beforehand from the local health department or whoever has jurisdiction.
Exactly. Like all this, when this got inspected by the Boulder County Health Department, they drew a diagram, an as-built diagram, and then did their own measurements off the house or a fence, you know, something, some type of structure, so that this tank can be found later down the road, or, you know, in the valve boxes.
You'll know what components to look for.
Exactly.
And no, you'll have a little better idea anyway of what defects you're likely to find, what failures you're likely to find.
And you can look at, by that too, you can see the installation date, kind of give you an idea how old the system is. That way you can ask, well, has the system been maintained by a clean? Because is the septic tank been cleaned every 3 to 4 years?
Has to see a log of the maintenance.
Exactly. A lot of counties actually require you to keep your pumping receipts.
Yeah.
So
good idea.
they would like to be able to see those. I mean, it's a good thing to do for people to, you know, to keep those, so they can, you know, if they sell the house, they can show that it is properly maintained.
Yeah.
A septic that's properly maintained, it you know, really can add life to it.
Yeah. Well, Greg, thanks for showing us this. It's a
You're
pleasure to
welcome.
see you again, and to see you again.
All right.